Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video, we're going to learn how to find the equation of an ellipse centered at the origin when we're given some information about the foci or the lengths of its axes. So first, find the equation of an ellipse that has a major axis with length 20. Your handout will have the right number on it. And foci at 6, 0 and negative 6, 0. So let's take a quick look at the sketch of this graph. 5, 10, 5, 10, 5, 10. The foci are at 6, 0 and negative 6, 0. That means they're on the major axis. So the major axis is the horizontal one here. We're told that the major axis has a length of 20. So 20 means that it's 10 on each side. So the vertices on the end of the horizontal axis, the major axis, are at 10, 0 and negative 10, 0. That also tells us that A is equal to 10. So what we've really got to figure out here is what is the value of B that tells us how far above and below the center to go. And we know that C equals the square root of A squared minus B squared, but that also tells us that C squared equals A squared minus B squared, and we can solve for B from here. C is 6, so 6 squared. A is 10, that's 10 squared minus B squared. 36 equals 100 minus B squared. Subtract 100. Negative 64 equals negative B squared. Multiply by negative 1, 64 equals B squared. Take the square root of both sides, B equals 8. So what we're really looking for here is the equation. And so the equation is x squared over a squared plus y squared over b squared equals 1. And we know that a squared was 100. A was 10. So this is x squared over 100 plus y squared over 8 squared or 64, right? Either of these two can give us that, equals 1. Number 4, find the equation of an ellipse that has a minor axis with length 18 and foci at 0, 4 and 0, negative 4. So I'm going to use the same kind of approach, not to scale, but the foci are at 0, 4 and 0, negative 4. And that has to be the major axis. So the minor axis has to be the horizontal one. Its length is 18, so that tells me that B is 9. So out here at 9 and negative 9. And what we've got to figure out is somewhere up here and down here, there's an A and a negative A that make this ellipse. So we do know from the last problem that we did that C squared equals A squared minus B squared. And if I solve this for A squared, I know that A squared is B squared plus C squared. In the equation, because the major axis is vertical, I know that the equation has to be of the form y squared over a squared plus, oops, let me just start over, too fast. It's x squared over b squared plus y squared over a squared equals 1. We already know that b is 9, so this is going to be 81. When we solve for a squared here, we're going to have the other denominator. So here a squared equals 9 squared or 81 plus 4 squared or 16. A squared equals 97. So in the equation, 97 is going to go there. But if we need to graph this, I need to know approximately where that is. And so I could use the calculator to get an approximate value for A. A is square root of 97. And let's say we wanted that to the nearest tenth. Square root 97 is about 9.8. So on the graph, we would go up to 9.8 and negative 9.8 to complete that graph. But what we really wanted was the equation. And so the equation is x squared over 81 plus y squared over 97 equals 1. All right, that's it for this one. I'll see you in the next video where we talk more about ellipses.